Hello everyone, and welcome to another episode of Mechanical Drawing 202. In this episode, I will continue to draw the spur gear that was being drawn or being designed in the last episode. In the last episode, we were up to the point when we drew the gear, the involute curve that will be used to draw the gear tooth profile. Now, I made a slight error in the last video. The measurements that I used in the last video to get the involute curve, I didn't realize that I was using the pitch circle diameter and I found the circumference of the pitch circle. However, I did the involute on the base circle, right? So since the involute was being done on the base circle, I should have used the diameter for the base circle. Didn't realize that I was choosing the wrong circle. So there are some slight changes to the calculations. So of course you have pi, and I even wrote here the base circle, but I was looking on the wrong circle. So the diameter for the base circle, and what made the situation worse, I wrote in the diameter incorrectly. So that's why I ended up with 304 rather than this value. So that's where I made the error. I used the wrong diameter. I mixed up the numbers. So this is the length for the involute. If you notice, I changed from pitch circle diameter because it's not the pitch circle diameter. The pitch circle diameter would be found on the pitch circle. So this is the length of one of the lines that will be used to draw the involute. Alright, so instead of the 15 point, I don't remember exactly 15 point what, but you'll use this so you can make the necessary adjustments if it is that you are drawing along with me. So here we have the involute. I have now the correct involute. So let's proceed. Alright, so we know before I transfer this involute to here, I am going to firstly draw the one complete tooth. All right. We still would need the pitch circle, or the circular pitch rather. Okay. All right. Since it is 20 teeth, since this gear consists of 20 teeth, naturally we divided the circle by 20. But each division represents the space for the teeth and the space between the teeth. Let me show you what I'm talking about. If you look here, you will realize that you have a space and you have the teeth. Space, teeth. So when you divide the circle in 20, each space will be shared between the tooth space and the tooth itself. Or what I should say, the space between the teeth and the teeth itself and the tooth itself. Alright, so instead of dividing this circle now in 20, I'm going to now divide it in 40. So let's go. Let's double the amount. And I'll explain to you why. Alright. If I divided it in 20, let me explode this. I'll have these lines. Alright. But since I need this space is supposed to be shared between a teeth and a space, a tooth and a space, I need to divide it in 40 so that I can get to know where the teeth will stop. In this case, the tooth width and the space between the tooth are the same, and as such, it's the same, and as such, I am going to hold on. I should have done something first. Let me undo all of this that is here. This line here before I even draw the involute. This line here, I will now connect it to the pitch circle. The pitch circle, this is critical. So after I've drawn the involute profile, whatever line was there before, I'm going to delete it. I'm going to draw a new line, and I'm going to connect it to the pitch circle, where the pitch circle meets the involute. Then whatever I said before will now become relevant. I'm going to divide this in 40. Okay, now I can talk. This space, if I divided it in 20, you'd have these lines only that I'm selecting. I won't select all of them, but just to show you. From here to here is the circular pitch. The circular pitch is the sum of the width of one tooth and the space between two teeth. So right here you would have a tooth, then the space, then the tooth, then the space. So the tooth space and the tooth width give you the circular pitch. So from here to here is the circular pitch. So in order to draw one teeth, you have to now divide the circular pitch in half. So that's why I divided it in 40 and not 20, so that I can get this line that represents the halfway mark. So this involute curve has to be over this part as well, passing through this point on the pitch circle. So it will go this way. So I'll draw a line, and this line I'll draw it from here to here on the pitch circle. I could have drawn it here as well, or here, it doesn't matter. And I'm going to select this line. I'm going to now select mirror, and from this central point to the center, you will see that I have mirrored the involute. So now you can now go ahead and trim. Can now go ahead and trim, so you can get this out of the way. So you can also get this out of the way. What's happening here? Alright, so this line is not trimming for some reason. Let me see if it's... Normally when I encounter situations like this, I'll just draw two lines at the point, then the trimming works. For some reason it does. Alright, so I can now convert this layer to this layer. So this is one teeth. So I have no need for these again. Alright, so this is what I'm going to do. If you notice the teeth is not complete, it should touch the root circle. I'm going to draw two more lines to this point, one to this point and one to this point of the base circle, so that the tooth can now touch the root circle. I can now go ahead and trim these lines. I can also trim this, and this is what I'll need to do. The fillet radius. I'm going to use 1 for this exercise. And there you have it. One single tooth. Now what I need to do is to position this tooth so that this vertical line, once it touches the pitch circle, it is in contact with the tooth. It's touching the tooth. Right now it's not touching the tooth. Okay, in order to do that, I'm going to draw this line here. I'm going to put it here because I want this to, if I knew the angle, and I don't want to estimate the angle, if I knew this angle, I could have just rotated this clockwise by this angle, but I don't really know it. I can measure it, but I don't want I don't want any decimals. So this is a little trick that I came up with. You can rotate this line so it's just below the horizontal. So this is below the horizontal right here. I rotated it 90 degrees, as you can see, on clockwise, but you don't have to. Then this same line, I'm going to mirror it to the horizontal. Alright, then I'm going to select the tooth. Notice I haven't selected the lines. Then I'm going to rotate from the center and then click here. All of a sudden, if you draw a straight line, it will meet the tooth at this pitch circle. That's what I want. Now I can delete these, and then I can go ahead and rotate the circle, all of this by 90 degrees. I can type the 90, or I can just click it while it is tracked. Now, once I've done this, I can now copy the tooth from the circle center, place it on this circle center, and voila, it is at the pitch point. I can now select this tooth, array this tooth, polar array, and I'm going to type, of course, 20. So let me do that slowly. I think I was moving a bit too fast. I selected the tooth. I've selected, and now I will now select array, click on the center, type items, then type the number, which is 20, and here you go. I have some trimming to do. I have to trim this point, this point, this point. So I'm almost through creating the first spur gear. So right, so we have completed the first spur gear. The second spur gear, the teeth will meet here. So let's see how quickly we can do that. So this is the second pitch point, the pitch circle. Then we are going to, using the addendum and the addendum, we are going to draw the addendum circle and the addendum circle. I'm going to offset the pitch circle by 5 on the outside. So 5 on the outside, and by the addendum I offset it 6.25 inwards. You could have calculated the circle, the diameters of the circle using these same formulas. The only difference, you'd use 80 instead of 100, and you will get the respective addendum and addendum circles. But it's easier to do the offset. I can, what should I do here? I'm going to copy this and place it back here. Okay, good. I'm going to also right click this circle and send it to the back. In terms of, you can do draw order, send it to the back so that the white lines show over it. Alright, so we have the addendum circle, the addendum circle. I'm going to use this line. I used this line to draw the base circle for the bottom gear. For the top gear, I'm going to use it as well. I'm going to copy it, and then I'm going to rotate it. "90 degrees, I can type the 90. Then I'm going to copy, or move rather, and place it at the center. Then I'm going to, what I should have done is, let me move it and place this end at the center. Now from here to here will be the radius of the base circle for this gear. And if you notice, we are using the same addendum and addendum due to the fact that the teeth for both gears will be the same size, even though the gears are of different diameters. So I don't need this line anymore. I have the base circle. Let me put it in its color that I designated for it. Then I'm going to copy all of this and place here. I am now going to draw the tooth profile. I'm going to draw a horizontal line, or vertical line rather, to the base circle. Alright, I'm going to extend it to the other end because I want to measure the radius, the diameter rather. This is 75.1754. So I'm going to copy this template. So it's the base circle now. The first formula can stay. So this is, I don't really remember what the measurement was. 75.1754. Five by 1754, and that should be, give me a minute, two hundred and 236.27. 236.27, and y'all divide that by 16. That's the number of teeth. And if you notice, the answer remains the same. So I did all of that just to prove that you will get the same length. Alright, so I can now bring this back to the halfway mark. Then I'm going to draw the line. I'm going to draw it this direction this time. 14.77. Then I'm going to select this line and I'm going to use the array feature, but this time it will be 16 divisions, right? Then I'm going to explode this. So the procedure is basically the same. So I'm going to copy this. Oh, not this one. Well, yeah, this one can work. Then this one. This is 3. This one will be 4. I normally go up to 6. I'm more certain that the involute is formed properly that way. Alright, so let's go. So this is 1, this is 2, so I'll start here. 1, 2, 3, 4, 5, and 6. Then I'll press enter. You can now proceed to delete everything that is here, except of course the involute curve. Alright, I noticed that I did not copy this circle. I like to have it there. This should have been here. Alright, so this is on the base circle. So this is what I'm going to do. From the pitch circle this time, from the pitch circle, where it cuts the pitch circle, going to draw a line to the center. Then, oh, this time around you could have done this. You could have trimmed it first. I didn't trim it first. Then I'm going to use this line from the pitch circle. You notice it's at the pitch circle where the pitch circle intersects the involute. Then I'm going to, this time the number of teeth is 16, so I'm going to split it in 32. The last time I split it in 40. Then I can explode this. Alright, so I'm going to draw a line here to here. That will serve as my mirror line. And then I'm going to mirror from the center to the here. Then you have that. You don't need these other lines anymore. Right. You can now proceed to trim. And you can now proceed to connect these lines here and here. Then you can trim. Then you can use the fillet radius. I'm going to stick with the fillet radius that I was using before. That is 1. Then I'm going to match this. Alright, so the same thing applies. Alright, so this is the point that should touch here, because the gear teeth will go in between here. So the top gear is spinning clockwise, or it could be spinning anti-clockwise, it doesn't matter. So if this gear was spinning clockwise, it would be transmitting motion to this gear, turning it anti-clockwise, pressing it against it at the pitch point. Alright, so let me show you what I need to do. I'm going to draw a line from the pitch point to the center, and I need this line to be vertical as well, or yes, vertical. So I'm going to rotate it so that it is close to the horizontal. Then I'm going to mirror so that it has one opposite to the horizontal. Then I'm going to select the teeth, and I'm going to rotate it from the horizontal to here. Alright, now if I delete these, then draw another line from the center, it will touch the circular pitch. So this horizontal line is touching the circular pitch. Now I can rotate it. This time I'll rotate it anti-clockwise. That is 90, negative 90, or you could type 270. Same result. Alright, now I can copy this teeth from the center and paste it here. Hold on. I think I did something wrong here. I'm going to rotate this teeth. Not rotate, rather mirror. This is how it should have been positioned. Alright, so I'm going to copy. Let me show you. Let me undo all of that so that I can show you where I went wrong. This is the side that should touch the teeth. This is the side. If you notice, here it is on the left, right, sorry, it is on the right, here it should be on the left. So I'm going to rotate all of this. Then I can continue as normal. I can draw a straight line here as well on the pitch point. Then I'm going to rotate this so I don't have to draw the line again. Okay, so here the line is touching the pitch point. Pitch point is the point where the gear touches the pitch circle. So I'm copying this, I'm rotating this rather. Then I'm going to copy from the center. Then now it should line up perfectly. Both gears are touching at the pitch point. And as you notice, it's also touching here because the backlash is 0. When designing a gears, the backlash should not be 0. It's just ideally it is designed to be 0. This is an ideal situation, not a realistic situation. In reality, this gear will the friction will cause the gear to be damaged. So since you have this one gear tooth, I am going to array this gear tooth from the center, and this time around I'm going to use 16. So I have some trimming to do. And And I also have some transferring of layers. All right, so here we have it. So let me turn off some layers. Let me turn off the addendum, base circle. I'll leave the pitch circle. All right, so here we have the pitch point, 20. The pitch angle, sorry. This is the pitch point right here. That is the pitch point. This is the pitch angle. Sorry, the pressure angle. This is the pressure line. All right. So this is a tangent to both circles at the pitch point, and the pressure line is 20 degrees to that line. It can be 25, it can be 14.5. 20 is the most often angle that is used. Different angles give different results in terms of the efficiency of the spur gear. Alright, so there you have it, both gears drawn using these calculations to determine the different parameters that are necessary. Alright, so you can apply this principle depending on the measurements that you get. Right, so I hope you grasp what was taught here today. So please like, share and subscribe for more content. And if you have any questions or any concerns, please do not hesitate to leave a comment in the comments section so that I can improve the quality of the teaching learning experience for the future. Okay, before we go, these circles, I think they are 20 millimeters in diameter. These are the circles, the holes in the spur gear that the shafts will go in to turn the gears. Normally one gear is a lead gear, the other is a follower, meaning one is turning, transmitting the movement to the other. So let's say, for example, this gear was spinning, the larger gear was spinning in a clockwise motion. It would be turning this smaller gear in an anti-clockwise motion. It will be pressing against the pressure point, and here you would have what we call clearance. That is another term that you need to know. No, not clearance, sorry, backlash. Clearance is this space here, and you have a clearance circle. This is the clearance. The clearance is the distance between the teeth of the opposite gear and the root circle or addendum circle, right? And the working depth is the distance between is the addendum and the dedendum combined, basically. Alright, so here are some other terms that you need to be familiar with. So this line that I've just drawn is, let me give it a separate color. This line is the clearance circle. This circle is the clearance circle, and the distance between the clearance circle and the dedendum circle is referred to as the clearance. So this space is ensuring that the gear is not touching the root circle, right? That is the portion I'm talking about, the bottom land. So the top land of the one gear, once the clearance is greater than 0, the top land of this gear will not touch the bottom land of this gear. Alright, so there you have it. Have a good day.